Hey guys, welcome to part 3. So in the part 2, we have created our private subnets and public subnets. And in this part 3, we are going to create our ECS cluster and create task definitions using our Docker container image. So I will click services here and I will search for ECS or Elastic Container Service. So I have a couple of clusters at the moment, but I'll create a new cluster. I will click create cluster and then I have few choices. Networking only, powered by AWS Fargate. So this is the one that we want to use because we don't want to manage our cluster compute resources like EC2 instances by ourselves. So we'll let AWS to manage it for us. So that's why we use AWS Fargate. So I will click next step, give it a name. I will just type my cluster and create a VPC. So here we have to create a VPC for this cluster. I will just accept the default CIDR blocks and I will click enable container insight and click create. And now I will click view cluster. Okay, I can see I am in my cluster. So now that I have created my cluster, we can create a task definition and then create a service out of this task definition and have our Docker containers run inside this cluster. So the first step is to create a task definition. Now this task definition is just like a Docker container. So if you click on task definition here, I can click create task definition, click Fargate launch type here and next and then give it a name. I will type hello world. Now I can assign a task role. So this is basically if I want to access AWS services from within my application that is running inside the container, then I have to assign a IAM role with the permissions. But the application running inside this container is only returning hello world to the request, so we don't need to specify a task role here. And the network mode AWS VPC is by default selected. And then I have to create a task execution IAM role. So you can click create a new role here. Then I have to specify some configuration related to the task or the container. So how much memory do I need to allocate to my container or the task? Let's say 0.5 GB and vCPU, okay, 0.5. Okay, I will pick 1 GB for task memory and vCPU 0.5. And then we have to add container definition. So click add container. You can give it a name. I will tell hello world. And then I have to specify where this Docker image resides. So basically repository URL slash image colon tag. So I will open up a new tab and go to ECR or Elastic Container Registry. And this is my container repository URL. And I will click on to that. And this is my image URI. I will just click here so it will copy the URL. I will go back to the ECS and paste it here. So it's referencing my YouTube image, the latest tag version. And I can specify memory limits and so on, but I'm not going to do that. But here in the container port mapping, so I will say, okay, my container is exposing port 3000. So that I want to map to any port from the host. So in this case, we don't have any access to host because that is managed by AWS in Fargate. So we just have to specify the container port here. And the rest, just leave it as it is. For example, you can add any environment variables, so on. But let's not focus on that now. I will click just add here. And then let's click create. So hello world is successfully created. Let's view the task definition. And there it is. So now I go back to the clusters here. And then you can see my cluster, the one I created here. I will click onto that. So now it's time to create a service. So I will click create and the launch type again I will pick Fargate. And the task definition, hello world, the revision, let's say the latest one. The revision number may differ in your case. And the platform, keep it latest. Cluster, my cluster, service name, let's call it hello world service. Now we have to specify number of tasks. So how many tasks should this service manage? So let's say I want to manage 2 tasks. So this service will manage two tasks. If one fails, it will remove it and spin up a new task from that task definition, this one. And minimum healthy percentage and these things will keep as defaults. And then the deployment section. The type of deployment that we are going to use is rolling update. So select on that and I will click next step. And here I have to pick the VPC. This is the time we are configuring the network for our tasks or the containers. So here I have to select my VPC. So in order to get the VPC ID, I will go to VPC dashboard here and let's see, this is our VPC. If I go to your VPCs here, my VPC starts with 00108. So let's search for that. And there it is, 00108. Okay. And now I have to pick the subnet. Remember, our task will be spinned up in the private network or private subnet. I will pick those private subnet 1 and subnet 2, and then I have to specify the security group. Here I can just edit the security group, and can you see at the moment the security group accepts HTTP from anywhere. But we want only our load balancer to access these tasks. So how can we do that? We can actually use the load balancer security group ID. But so far we haven't created our load balancer. So we can edit this security group later. Hello W2131. For now, let's keep the source anywhere. And I will click save. Now, in order to create the load balancer that balance our request across the tasks, I will select application load balancer under load balancing and health check grace period. So this is basically how much time the ECS service scheduler should ignore elastic load balance unhealthy targets checks, because it takes some time to spin up a task from the task definition. So we'll just say stay about 30 seconds. So I will pick application load balancer. Out of three load balancers, I can either pick network or application or classic. Classic will not work in this case because this is AWS Fargate. So it has to be application load balancer or network load balancer. This load balancer supports balancing traffic out to different resources on IP addresses. In this case, tasks on specific IP addresses within our VPCs. So I will pick application load balancer here. And balancer name, well, I don't actually have a load balancer at this moment. So there's this message, no load balancer is found. So a link is given to me. So I will just click on that in a separate tab and then we'll actually create a load balancer. So here I will pick application load balancer and give it a load balancer name, my ALB for application load balancer. And the listener port HTTP 80 is already created for me. So load balancer will listen on HTTP on port 80. And now I have to pick the VPC that this load balancer should run. So my VPC, and what are the availability zones that it should create load balancer nodes. So I will pick both US East 1A and US East 1B. And let's pick the subnet. Make sure you pick public subnet 1 and here public subnet 2, because we want everybody on internet to access our load balancer on port 80. It has to be publicly accessible. Only our tasks are in the private subnet, which can only be accessed by this load balancer. So then I will click configure security group and click again configure security group. I will check create a new security group. Let's say my ALB SG for my elastic load balancer security group, and I will add HTTP on port 80 from any resource. So 0.0.0/0 represent any IP addresses from within internet. So I have added this inbound rule so anybody can access my load balancer. And then I will just click configure routing, and this is the place where we have to create our target group. Now any request that load balancer will receive will be sent out to a target group. So we don't actually have any target group set up. I will click at new target group, give it a name, my ALB target group, my ALB TG. And here, this is very important, we have to select IP, because the service that we created in ECS will create tasks from within our VPC. So it will use specific IP addresses within our private subnet that we define for tasks, and it will allocate those IP addresses to those particular tasks or containers. So our load balancer should be able to spread traffic to those IP addresses. Okay, protocol is HTTP and port is 80, and the health endpoint, it is health, if you can remember. So our application, the Express application, has a route called /health. And then I'll click next register task. So I'm not adding any static IP addresses right here because we'll allow our ECS to dynamically add those IP addresses registered in the load balancer, right? So we are not statically type anything here. Let's just click create. So it's going to create my load balancer right there. Okay, I'll click close here, and this is the ALB that is created. I'll go back to the previous tab I opened here, and I will click refresh button. There we go. It actually selected my ALB, and it has already picked that task definition hello world and the port that we have exposed it 3000. So that is good. Then I will click add to load balancer button. Now I can select 80 port 80 HTTP. So that is the listener port of my load balancer. So load balancer is listening on port 80 and the listener protocol is HTTP. So any traffic that is reached out to my load balancer on port 80, we should direct to my ALB target group. There I create the my ALB. So you can see the target type is automatically detected, and a health check path has already been automatically detected because we have already configured this when creating our ALB. So that seems all fine. And under service discovery, we'll unselect this because we don't have any other microservices to work with this microservice. If there is, then this will be really useful to address microservices separately. So then I will click next step, and auto scaling options I will keep the default and click next step, and finally I will create my service. Now I will view my service. You can click details here, and I can select my cluster again to view my service. I will click my cluster. You can see one service is already there, and this is my hello world service. And as you can see, the desired task count is 2. So this service is managing 2 tasks, but at the moment 0 tasks are running. Now I go to tasks tab just to see how it is going. And as I can see, the status is still pending and the desired state is running. And I will do a couple of refresh, still pending. And after some time, you should see one task disappeared. Well, if you go to stopped section, you will see, tasks are stopping. Now this, 2 tasks has been stopped. Now what is the reason here? My tasks are not running. They are not coming into the desired running state. Now this has to do with internet accessibility within my tasks. Now we spin up task in a private subnet which does not have any connectivity to internet. But if we look at our Docker file, and there is this particular line that runs npm install, which pull all the dependencies of my package.json file like Express and then install it. So when my service is spinning up tasks from the task definition, so it's going to run this Docker file. But at this point, it cannot do it because there's no internet accessibility. Hence, the task fails. So that's why our tasks are never coming into running state. So what is the option? We don't want to have our task in a public subnet that everybody can access. So as a solution, we have to add a NAT gateway for our public subnet. So the NAT gateway is basically allow our resources in the private subnet to access internet and grab any updates. But anybody else outside internet cannot access our task using this NAT gateway. So that's how the NAT gateways are designed. So let's do that. I will go to my services and select VPCs and open it in a new tab. And then from the left sidebar, I will select NAT gateways. I don't have any NAT gateways created, so I'll create NAT gateway. Okay, now we have to specify a subnet where this NAT gateway should run. So always a NAT gateway should run in a public subnet with internet accessibility, because NAT gateway should be able to access internet on behalf of our private tasks. So it has to have internet accessibility. So in this case, I am selecting my VPC public one because it has internet gateway attached. And then I have to allocate an elastic IP. So I will click create new IP button. It will create a new IP, EIP, and assign it to this. And then I click create a NAT gateway. Okay, so it's created. Now I can just click edit route table button, and then let me filter my VPC. I will select here my VPC. Then I will only see the route table associated with my VPC. So now I basically have to change my private route table, which is associated with my two private subnet. Now I can see the subnet association if I click on this button. There you go. Both my private subnets are attached to this private route table. I will go to route section. So at the moment it only associate one route CIDR, that is routing locally. So I will click edit routes and I will add a new route 0.0.0.0/0. That means any IP address other than an IP address from this range, and that should be sent to the NAT gateway, not to the internet gateway, but to the NAT gateway onto this NAT gateway ID, and then I will save routes. Okay, so I have this new rule added in my route table. Now our task should be able to reach out to internet. So let's go to our ECS tab here, and we'll see if our services are now getting active. So at the moment still I don't see any running tasks. So let me go to tasks here. So it's still in the pending state. Let's do a couple of refreshes and give it a couple of minutes. There you go. I got one task in the running state. That's a good sign. The other one should also be at running state in no time. Let me do another refresh. Alright guys, so both of my services are on the running status now. We have to do one other change. Now if you can remember, we have allocated a security group for this service. So we have to make sure that security group has an inbound rule from the security group attached to the Elastic Load Balancer. I think at the moment we have set up only the HTTP access from anywhere, but that's not going to be enough. So in order to update the security group inbound rule, I can simply click update here because I'm in the service hello world. So let's update this service. Click on that. So give it a second to load all these variables. So I will select next step without changing anything. And here under configuration, the network section, you will see the security group of that. So I will just open that security group in a new tab. Now this security group is attached to our service at the moment. Now I went ahead and added the security group ID of my load balancer to accept all TCP traffic as inbound rule. Now let me show you how to find the security group of our load balancer. You can open up a new tab. I will go to services and open EC2 in a new tab. And now let's go to load balancer section on the left side. Now I will expand this section a little bit and scroll it down a little bit again, and then under security section you should find the security group attached to this ALB. Now I will open this, so it is SG076. So let me open this. There we go. So this is the security group attached to that, and its name is my ALB security group as well. So I can check the inbound rules attached to this security group. You can see HTTP is allowed on port 80 from anywhere. So that's all fine because my ALB is accessible to anybody in internet. But now what I want to restrict is accessing to my private tasks, or rather the service that manage my tasks. So I only want this ALB to access my tasks in the service. So what I'm going to do is I will copy this security group ID and then go back to my service security group. It is this one, and I will click edit all rule and I will select all TCP, and then here I will paste that security group ID. So this is the security group ID of my ALB, and I'll save the rules. So after that, I can go back to my load balancer. Here we go. And I will click listeners here. Then you can see there's a listener set up for HTTP port 80, and that will forward traffic to my ECS Hello World target group. So let me click on that. So all traffic coming from that port 80 will be forwarded to this target group. And there we have the target group. If I check the targets right now, and the targets are all healthy. And you can see the IP addresses 10.0.3.207 and this IP addresses where my two tasks are running on. So now everything is connected. Just to confirm everything is working fine, I will go to load balancer again and then I will copy the DNS name and then I will go to one of the browser window and hit enter. There we go. I have my hello world message printed out. So just to summarize the flow again, anybody in the internet can use the DN of my load balancer, and once the request is made to the load balancer, what happens is that request will be forwarded to a target group attached to that. So I will click on the target group, and in this target group, ECS will automatically register these two IP addresses that is attached to the two tasks managed by our service. So let me show you the service. So this is my ECS and I'm in my cluster and ECS has this Hello World service. So this Hello World service, let me click onto that. It has two desired task count managing. So always this service will make sure it's running two tasks. So if I come here and stop one of these tasks, I will click here and then click stop. Then my service will only have one task running. So let me show you here. You see there's only one running task, but the desired task is two. So what will the ECS scheduler does is it will spin up another task. I will go to task section. Probably we can see it provisioning a new task right now. So still one task. So let's do a couple of refresh. There we go. So it's provisioning a new task. So yet I can access my website that is in one of the tasks from the ALB DNS and I have a highly available system. So that's it for this part. So in the last part of this series, we will automate everything using AWS code pipeline. I'll see you in the next episode.